I should say I'm the co-founder with Sam White of the Climate History Network. Thank you so much, Sam, for the introduction, and thank you for inviting me here. Thank you all for coming here. Today, I'm going to try to connect climate change to conflict. I'm going to try and do that by drawing some lessons from the Lible Ice Age. I'm going to take you back into some of the work that I do on a cooler climate hundreds of years into the past. And this talk is happening in the wake of a very exceptional year in the climate history of Earth. Here you can see a map of global temperatures relative to their 20th century averages from January to December of 2015. And as you can see, records were broken all around the world, especially above the oceans. And this is in part a function of a very extreme El Nino event, but it's also caused by global warming. You can see there's one exception to that trend, this little pulse, or actually pretty huge pulse of cooling off Greenland in the northern Atlantic. That's actually fresh water from ice melting into the northern Atlantic Ocean. This is 2015 relative to other record-breaking years in the instrumental record of our planet's climate. All of these years are from the last 20 years, and you can see that 2015 absolutely shattered records, much, much warmer than 2014, the previous record holder. This is a pretty confusing map created by the National Oceanic and Atmospheric Administration, but it gives you examples of local and regional environments that were transformed by the warm temperatures that we just experienced. You can see here, for example, torrential rains in China, drying in the United States, a record-breaking typhoon season, and really fast melting in Greenland, and a heat wave, extreme heat wave in India. So the world is changing, and defense departments are taking notice. The quadrennial defense review of our Department of Defense in the United States has the following things to say about climate change and its role in making conflict more likely. Climate change may exacerbate water scarcity and lead to sharp increases in food costs. The pressures caused by climate change, according to the quadrennial defense review, will influence resource competition while placing additional burdens on economies, societies, and governance institutions around the world. These effects are threat multipliers that will aggravate stressors abroad such as poverty, environmental degradation, political instability, and social tensions. Threat multiplier is a military term that really just means that one influence will compound other influences. The impacts of climate change may increase the frequency, scale, and complexity of future missions. Last night, I was strolling around the internet while staying at Sam White's place, and I noticed there's a new DoD Directive 4715.21 that was just signed by the Deputy Secretary of Defense, Robert Work. It orders officials to consider climate change in all new purchases and missions. So in other words, militaries around the world, and especially perhaps our military, are taking notice of the destabilizing, potentially destabilizing and transformative impact of climate change. Now, this has been in the news a lot lately. Climate change may be influencing and may be a major factor behind the Syrian civil war. From 2006 to 2009, there was a very severe drought that stretched across Syria, one of the most severe in the instrumental record of that country. Using computer simulations, scientists recently, just last year, linked that drought to the regional effects of global warming. Global warming has a different impact from region to region. It influences weather differently from region to region. In the Fertile Crescent, we expect that drought will become more common. And maybe this drought was made more likely by a warmer climate. Some 10% of the Syrian population responded to that drought by moving from the countryside to the outskirts of already overcrowded cities. Overcrowded because there was another 1 million refugees that had been coming from Iraq in the wake of the American invasion of Iraq. So they're out of work. They're desperate. They're living in poorly planned, crime-ridden neighborhoods. Several groups of scientists have concluded, primarily from interviews with refugees, that refugees were quick to revolt against a brutal regime in part because of these conditions on the outskirts of cities that were not being properly addressed by the regime. This is the argument. It's still controversial. It's been criticized from many different corners of academia in particular. But it's something that militaries are certainly taking notice of. Now, military investigations of these relationships, of these issues, have been largely focused on the present and on projections of the future. But I'm going to be arguing that we can look deep into the past to try and find some answers, to try and figure out how climate change might make conflict more likely, and then also how climate change might influence the conduct of conflict. Now, one of the most significant climate changes since the beginnings of human civilization is called the Little Ice Age, and in a few minutes I'll go over what that Little Ice Age actually was. Now, this is a particularly interesting climatic regime for climate historians, environmental historians like myself and like Professor White, because societies during the Little Ice Age kept rigorous documentation of weather and its impacts on, in my case I'm very interested in, on conflict. And so I have studied the Dutch Republic. And my research on the Dutch Republic suggests that climatic oscillations during the Little Ice Age might have helped trigger wars and might have then influenced how those wars were fought and how they were decided. So I'm going to cover that, and then I'm going to try to provide some lessons for what we can learn from the past. Okay. How do we know that climates have changed in the past? I think a lot of us, when we think about climate change, we really think about a relatively stable climate. The climate has stayed the same for thousands of years until the last 50 years when it's really spiked. This is the idea behind the hockey stick graph. But in fact, that's not really the case. And we know this through proxy data from natural archives. Proxies are things that respond to changes in climate, and not necessarily directly, but in ways that are left in a sort of natural record. So for example, tree rings. If you look at a tree trunk, you might find rings in that tree trunk, and the width of each ring corresponds to how much a tree has grown in a particular year. Now, if you know something about the tree, you might know what kind of weather it responds to. If it was warmer, the tree might have grown faster. If it was wetter, the tree might have grown faster. And so if you look at enough of these tree rings, you can get a sense of how climate changed over time, going back potentially hundreds, and in some cases even thousands of years. Another excellent proxy is an ice core. And that's because samples of Earth's atmosphere are trapped in bubbles within ice, and you can actually drill into ice, in glaciers, for example, and unearth these samples of the atmosphere going back hundreds and even hundreds of thousands of years. Now, another useful source for reconstructing past climates are proxy data from so-called textual archives. And these can be equally diverse. They can include weather diaries, for example, diaries where people took note of weather. They can include correspondence where people took note not only of extreme weather, but also of average weather conditions. They could include registers of harbor tolls paid, for example, and those could fluctuate based on the presence of sea ice. So we can use these two sets of data in concert, and then sometimes also with computer models that are based on our knowledge of how Earth's climate works. These computer simulations can tell us something about the future, but they can also be used to hindcast climate change going back hundreds, thousands, even millions of years. And then for more recent periods, we can use instrumental data. And that only really becomes useful in the 18th century which is a little bit late to be of interest to me. Okay, so all of this information tells us that there was a little ice age. From about 1250 to 1850, climates across the northern hemisphere and in many other parts of the world declined, or cooled, I should say, by about 0.5 degrees Celsius. I'm Canadian, so I still think in Celsius. But anyway, so there's this cooling of 0.5 degrees Celsius. And then from 1560 to 1720, there's an especially extreme pulse of cooling, nearly 1 degree Celsius across most of the northern hemisphere. So that, as you can see here, is the Little Ice Age. Now, it was caused by many different things, and some of these causes remain controversial. One of the most important was undoubtedly volcanic eruptions. Now, if you have a sufficiently large volcano at the right latitude, the sulfur it releases into the atmosphere can reflect sunlight in a way that cools the planet for several years. If you have major volcanic eruptions in quick succession, they can collectively jolt the climate system into a cooler climatic regime. They can also trigger feedback loops where expanding sea ice, for example, reflects more sunlight into space than the land or the water that it replaces, which in turn has a cooling effect, which then leads to more sea ice. And so this undoubtedly happened in the late 13th century. It probably happened in the early 17th century, and it likely also happened in the early 19th century. Scientists have also argued that changes in solar radiation were an important force behind cooling, especially the greatest periods of cooling during the Little Ice Age. Some of the coldest phases of the Little Ice Age coincide with periods of low solar activity. And a really interesting idea that has recently gained a lot of currency is the notion that maybe, just maybe, human activity played a role in cooling the planet. This idea comes from the depopulation of the Americas in the 16th century. And the notion is that mass depopulation of the Americas by the Spanish, through Spanish diseases and through Spanish violence, led to reforestation in the Americas. About 60 million people dying and their land use patterns vanishing with them. Reforestation that overcame the influence of deforestation in India and in China, and thereby pulled a lot of carbon dioxide out of the atmosphere, about 10 parts per million, apparently. And the notion is that this was enough to trigger the cooling of the coldest phase of the Little Ice Age. So this is something that's very recently been gaining a lot of currency, I think, in the scientific community. Okay, so there were many different factors behind the Little Ice Age. Now, as Professor White noted, my book is called The Frigid Golden Age, Experiencing the Little Ice Age in the Dutch Republic, 1560 to 1720. In that book, I find connections between the cooling of the Little Ice Age and different aspects of the history of the Dutch Golden Age, which curiously overlapped with the coldest phase of the Little Ice Age. Now, the Dutch Republic thrived during the chilliest phase of the Little Ice Age, even though it was almost always at war. According to one historian, the Dutch fought a perpetual war of independence for their entire Golden Age. Extensive textual sources, so to some extent textual proxies, survive that let us examine in great detail how climate change influenced the course of the Dutch wars in the 16th, 17th, and even the early 18th centuries. And so it's that I'm really going to be focusing on in this talk. And this, by the way, is a beautiful 16th century depiction of Amsterdam. Now, in order to look at these interactions between climate change and conflict, I really work through three distinct relationships This is an area where my methodology is quite different from other historians and scientists who have tried to reconstruct relationships between climate change and human history. I try and build connections first between gradual global climate changes and immediate local environmental changes, by which I really mean I try and figure out how global climate changes actually transformed weather at a local and regional level. So that's the first thing I try and do. And for that, I primarily look at scientific articles. And I consult with scientists. Then, for my second relationship, I try and figure out how immediate and local environmental changes, so again, mostly weather, actually impacted human activities on the same scale. So for example, and this is, as I'll show you, this is what I do in my book, I try and figure out how weather actually influenced a particular military operation. And then I look for a whole lot of those relationships. Dozens of them, hundreds of them, sometimes even thousands. And at the end of that process, finally, I feel confident in trying to establish my third big relationship between gradual and global climate changes and human history over the course of decades and even centuries. So this is just a way of working through differences in scale, trying to account for the huge difference in scale between climate change and human activities. Now, a key part of my methodology is that I try and follow these relationships not only in years and decades of extremes, in particularly cold decades, for example, but also in years of relatively average or even warm conditions. And I do that because I'm really trying to isolate the influence of climate change. And I think it's very difficult to do that if you only look for extremes, if you only look at decades that are marked by very cold temperatures, for example. Okay. On the right is a map of the Dutch Republic in 1648. This was created for me by Hans van der Marel, a Dutch mapper, I guess. And on the left, you see graphs of seasonal temperatures in the Low Countries from 700 to 2000. So winter at the top, then summer, then spring, and then fall. And what I've highlighted here are three especially cold phases that overlapped with the history of the Dutch Republic. The first is called the Grindelwald fluctuation. And it lasted from approximately, these dates are all quite approximate, approximately 1565 to 1628, which has been called a year without summer. It's this Grindelwald fluctuation which is often linked to anthropogenic activity in the Americas, the depopulation of the Americas. The second cold phase is called the Maunder minimum. It's named after an astronomer who realized that there were by looking back at sunspot records going back hundreds of years, he realized that there were very few sunspots during this relatively cold phase in the Little Ice Age. And so that was called a minimum in solar activity. When solar activity is low, there are very few sunspots. It lasted from 1660 to 1720. And the third really cold phase of the Little Ice Age is called the Dalton minimum. And it lasted from 1760 to 1850. Again, these dates are approximate. Now, during these three cold phases, temperatures in the Dutch Republic and really in the North Sea region declined by around 1 degree Celsius, overall annual average temperatures. But this is about much more than just temperature, because cooling also set in motion other changes in prevailing weather. Changes in wind velocity, for example. There were more storms during these chillier phases. Changes in precipitation. It was probably wetter, at least outside of winter, during these really cold phases of the Little Ice Age. And crucially, these cold pulses were separated by warmer, drier, and less stormy decades. So that really cold period of the Little Ice Age that I described earlier in this talk, when we zoom in to particular region and we break it down by season, we find that it's a little bit more complicated than that. Okay, now I want to take a big step back, and I want to go over some of the ways in which climate change might contribute to the causes of conflict. There's a few ways that this can happen. First, by destabilizing a society. By undermining agro-pastoral systems, usually by shortening the growing season, and thereby causing famine, or at least contributing to famine, and thereby contributing to depopulation and migration. Migration and famine and depopulation, all of this can lead to civil war and can also lead to foreign invasion. They can be contributing causes. They can't do it all by themselves, but they can certainly nudge a society into instability. They can also lead to large-scale devastation. Climate changes can lead to weather that can cause large-scale devastation that can be blamed by some survivors on government policy. It's these first two things that I really focus on in my work, as you'll see in a few minutes. Now, interestingly, climate change can also contribute to the causes of conflict by strengthening a society. So strengthening those same systems that I talked about, which can lead to expansionary pressures. Nicola Di Cosmo at Princeton is doing some very fascinating work that links Mongolian expansion and Mongol invasion of China to actually increased rainfall, suggesting that there was simply more food for horses. And that might have then pushed the Mongols to expand beyond their previous borders. Now, climate change may also contribute to the causes of conflict by threatening a shared resource, a body of water, for example, a pastoral commons. That may be overexploited, and that can lead not only to conflict within a society, but conflict between societies that might be sharing that resource. And this has been a focus of recent research on African ramifications of climate change, the ways in which climate change might make violence more likely on the African continent. Then, interestingly to me, climate change can contribute to the causes of conflict by increasing military tensions, by bringing competing forces into close contact. A weather event, for example, a storm at sea, which might have become more likely in my case, a cooler climate, that might have led forces into close proximity. And I'll talk about that in just a couple minutes. Okay. My first example of these relations comes from the 80 Years' War, also called the Dutch Wars of Independence, which lasted from 1568 to 1648, although instability preceded 1568 by several years. This was a war in which Dutch rebels tried to defend their rebellion and after 1579 their republic from the Spanish Empire, which used to own the Low Countries. Now, I argue in my book that climatic cooling influenced harvest failures in 1565, so the first year of the Grindelwald fluctuation, and in 1566. And these harvest failures exacerbated popular discontent over religious issues, particularly the Inquisition that the Spanish regime was imposing on the Low Countries at the time. There are many primary sources that I looked at, many accounts of how riots began because of food shortages and high food prices, and then spilled over into religious riots directed against the Inquisition, often when their leaders were Calvinist, and might have also contributed then to what's called in Dutch the Beeldenstorm, or the iconoclastic fury of 1567. This is a depiction of that iconoclastic fury when mobs of Calvinists invaded Catholic churches and smashed religious iconography. So there's a potential link here between climatic cooling, shortening growing seasons, raising food prices, and then potentially contributing to religious turmoil in ways that ultimately contributed to the beginning of armed insurrection. Now, interestingly, I found that severe storms that might have been, or very likely were, made more common by the climate of the Grindelwald fluctuation, by this cooler climate, contributed to major inundations of the Low Countries and contributed to a massive loss of life. And this actually happened after 1568. So in the years following 1568, this repeatedly happened. And what actually happened with the 80 Years' War is that you had an initial insurrection in 1568 that was quickly crushed, and then things sort of simmered for a couple of years until 1572. And as things were simmering, you had these enormous inundations. And each inundation caused popular indignation about the Spanish regime's failure to properly maintain flood defenses, and thereby contributed to this revolutionary sort of attitude and anger in the Dutch Republic. So we have these relationships that I just described, perhaps making warfare more likely and contributing to the causes of war at the beginning of the Dutch Wars of Independence. Now, the second example comes from the Anglo-Dutch Wars. And these were actually 3 wars that were fought from 1652 to 1674. After the English Commonwealth passed protectionist legislation, notably the First Navigation Act, aimed at limiting Dutch trade, notably with English colonies, a large Dutch fleet was sent to sea by the Dutch States General, which was the governing body of the Dutch Republic. And the goal was to intimidate England without actually starting a battle, without actually fighting the English fleet. However, after the fleet took to sea, a storm blew the Dutch towards an English fleet. And in the confusion, a battle erupted. And it's this battle that was really the start of the First Anglo-Dutch War. Now, the storm cannot be linked to climate change. I have to admit, the storm cannot be linked to climate change because storms were actually less likely before the onset of the Maunder minimum. And the Maunder minimum, if you remember, started around 1660. However, this is an example of the kind of relationships that we might be able to see if we look into the past, and potentially even that we might see in the present, at some point in the present. Okay, well, what I'm particularly interested in the Frigid Golden Age is the ways in which climate change can affect the conduct of conflict. And there's a few ways in which these relationships could unfold. First, by shifting popular opinion. Whether it could actually undermine faith in a particular religion or government. And I mentioned those inundations just a few minutes ago. Well, the inundations, when they reached Hoorn, caused widespread humiliation of the Catholic faith in Hoorn, because the leader of Catholicism in Hoorn actually went out to the town square to drive the waters back with the Holy Bible. And as you might imagine, he failed. And then there was widespread mockery of his faith, and that kind of contributed to widespread discontent. Now also, and crucially, and this is really my focus, climate change can alter the conduct of conflict by altering the battlefield, by creating conditions that unequally affected the practices and technologies, the ideologies of belligerent armies. And I'll get to that in just a few minutes. And then also by creating conditions that benefited one kind of operation, but not another. Now, another important way in which climate change can influence the conduct of conflict is by changing the effectiveness of key military infrastructure. Natural and artificial fortifications, for example, but even armories and shipyards. And again, I'll get to that in a few minutes. And then, and this is something I don't really focus on in my work because it's difficult to get precise documentation for the early modern period of these things, but by affecting the supply of fuel, of food for armies and civilians, and by affecting the transportation networks used to supply food and fuel and ammunition and reinforcements, and even money to armies in the field. And it can, these relationships can unfold by, for example, the torrential flooding of routes of resupply. And we do actually see some examples of that during the Dutch Wars of Independence. But for the most part, I'm interested in climate change at the tactical level. I'm interested in relationships between weather events and battles. And the reason for that is that battles are extremely well documented. We've got excellent documentation not only of what happened in battles, but also of the weather that affected battles. Detailed analysis from people who were involved in battles, describing the kind of weather that they tried to exploit and that they tried to endure. Okay. Dutch Wars of Independence, if you remember, were actually fought during a period of climatic transition. From 1568 to 1628, they coincided with a cold and wet and stormy Grindelwald fluctuation. Just as the Dutch Republic was on the defensive, primarily, against Spain. The rebels at first were trying to defend their rebellion, and then after that, once the Republic was sort of announced, then the Republic was trying to defend itself against overwhelming Spanish might, Spanish armed forces. But thereafter, after 1628, a slightly warmer and drier interval of the Lible Ice Age kind of separated that Grindelwald fluctuation from the Maunder minimum. And that was exactly at the point when the Dutch Republic went on the offensive against Spain. This was made possible for a number of reasons. The Spanish were distracted by the War of Manchuan Succession, and they decided to fight a defensive war in the Low Countries. At the same time, the Dutch Republic decided to ally itself with France. And the Dutch were simply much richer than they had been. The Dutch trading companies had expanded across Asia and across the Americas. And so there was just a lot more money in the Dutch Republic that could finance mercenaries. So this is an example, actually, of some of the battles that I looked at and that I'm interested in across the Low Countries and even at sea during the Wars of Independence. And all of these battles were impacted in some way by weather that was made more likely during the Grindelwald fluctuation. Now, freezing had complex military ramifications. Freezing that became more severe and that lasted longer during the Grindelwald fluctuation. Major rivers in the Rhine-Meuse Delta actually provided important obstacles for invading armies. And the Republic's army fortified these obstacles as well as they could. However, they weren't much use when, in cold winters, freezing let Spanish and even German armies cross the rivers with impunity. Dutch soldiers and civilians and sometimes even horse-drawn icebreakers were conscripted to break the ice, but this was usually not enough. And so freezing actually made the Republic, in some respects, more vulnerable to invasion. And ships, often Dutch ships, and you can see one here in the background, could be trapped by ice during sudden freezing, and they were then vulnerable to Spanish raids. So the Dutch rebels had, and later the Republic, had local and to some extent even regional naval superiority over the Spanish, but this was not much use when ships would freeze in the ice. However, and most importantly, cold weather inflicted a terrible toll on invading armies. And one of the reasons is that this is right around the time of the military revolution. Siege warfare becomes much more important as the Italian star-shaped bastion is introduced into the Low Countries. And so you have Spanish armies that besiege Dutch cities sometimes for entire winters. The siege of Haarlem in 1573, for example. And the toll that an especially severe winter takes on the troops is enormous. And many of them do end up dying. And the ones that survive often end up mutinying, in part because they refuse to endure another severe winter on the field. So on the balance, I argue that freezing weather and the cooler climate of the Grindelwald fluctuation provided a tactical advantage, in some cases a strategic advantage, for the Dutch rebellion and later the Dutch Republic. Now, rains and storms, I argue, also aided the defense of the Dutch Republic. In the summer, here's an example, in the summer of 1574, a Spanish army besieges the rebel-held city of Leiden. Rebel soldiers breached dikes to inundate the area around Leiden, actually all the way from The Hague, where they're based, to Leiden. And they then sailed to relieve the city of Leiden. They actually build 200 boats and ships, and with them they actually take to these artificial waters to try and relieve the city of Leiden, which was then besieged by Spanish troops. Now at first the floodwaters spread very slowly, but suddenly rains and storms aided the inundations, and they advanced very quickly, and the Spanish were forced to retreat abruptly in haste, leaving behind their equipment. So it's these rains and floodwaters that were really crucial for relieving the city of Leiden. They were not the only factor, but they were a crucial influence that allowed the Dutch to prevail in that siege. This is probably a better map. You can see here the boats leaving from the vicinity of The Hague and traveling up towards Leiden at the top, right there. And you can see Spanish soldiers sort of fleeing off towards the North Sea. Another example is the Battle of Nieupoort in 1600. This is a depiction of that battle, which is one of the most famous military victories in the history of the Dutch Republic. It was fought in Flanders, along the coast actually of the North Sea. In the aftermath of the battle, the army of the Dutch Republic tried to exploit its victory by seizing Spanish-held towns, Nieupoort and Dunkirk. However, torrential rain and flooding made more frequent, more likely, during the Grindelwald fluctuation, forced them back. Antonis Duyck, a high-ranking official with the Dutch army, on the 7th of July reported that, quote, "It continues to rain. So much water has fallen that the army at Nieupoort can scarcely do anything." After Maurits, the Dutch captain general, ordered the construction of shelters, the soldiers kept busy by protecting themselves against the driving rain. 1 week later, the weather is so bad that God himself is preventing the work. And a few days later, amid still torrential rains, the army was actually forced to board vessels and return to the Dutch Republic from Flanders. So here's a military offensive foiled in part by torrential rains and storms. And this shows then also that Dutch offensives could also be slowed and hampered and undermined by weather that the Grindelwald fluctuation made more common. But most often, offensives of this nature were attempted by the Spanish, at least during the Grindelwald fluctuation. And so overall, this had a positive impact on the ability of the rebellion and the Dutch Republic to defend itself. Now, after that year without summer, as it's called, 1628, the final year of the Grindelwald fluctuation, as I mentioned, the Dutch have suddenly an important advantage over the Spanish in the Low Countries. The Republic's army, just to take one example, encircles the major Spanish-held city of 's-Hertogenbosch. That city was defended primarily by water, by marshes, by a system of artificial inundations and fortifications that bordered on the water. But Drought actually allowed an army under Frederick Hendrik to surround the city with trenches, and they actually diverted water from the rivers that otherwise fed the marshes around the city and just diverted it around the city, and so it dried out the whole area around the city. And this would have been incredibly difficult to do if water levels had been much higher and if the rains that I described earlier had reappeared. This also made it much easier to build trenches around the city, which was how sieges were established in the period. And the city then fell on the 14th of September. So after a long siege, but it fell nonetheless. Here's a depiction of the siege. You can see the city in the background, and you can see the waters of the river diverted there around the city. So they no longer actually feed the city itself. So, I argue in my book that during the Grindelwald fluctuation, climatic conditions that usually aided defensive operations benefited the Dutch Republic. But the transition to a warmer and drier and less stormy climate coincided with a new strategic situation in the Low Countries. And in that context, Dutch offensive operations, I argue, benefited. So somehow the Dutch were able to benefit not only from a colder and rainier and stormy climate, but also from a warmer and drier climate. Okay. In the Frigid Golden Age, I also look at those 3 Anglo-Dutch Wars. The first Anglo-Dutch War was fought in that warmer and drier and less stormy climate. The second and third Anglo-Dutch Wars were fought during the Maunder minimum, during a colder and stormier and wetter climate. However, those weather conditions now are somewhat less important for me, because at sea, wind direction and wind velocity matter much more than temperature or precipitation. And almost all of the battles during these wars were actually fought at sea. In these seas, right here, as you can see, these are some of the major locations of battles during these wars. And why was wind direction and wind velocity so important? Well, during the age of sail, it was crucial for fleets to try to claim the weather gauge. So on this depiction of a battle during the Second Anglo-Dutch War, if I'm not mistaken, and imagine if wind direction goes from left to right in this picture, then the English ship on the right is in the lee position, and the Dutch ship on the left is to the windward position, which means that the wind is at the back of its crew, which means that they have the weather gauge. So the wind being at your back means that you have the weather gauge. And what that does for you is it allows you to have the tactical initiative. It allows you to decide when you attack and how you will attack. And to some extent, it even allows you to flee. And so this is really crucial in these wars. And what I had to do then is I actually had to use ship logbooks to try to reconstruct changes in wind direction and to try and figure out how changes in wind direction might have overlapped with and coincided from and followed from the cooling of the Maunder minimum. Now, ship logbooks were really useful for me because they contain a huge amount of information not only about the characteristics of a ship journey, but also about daily and sometimes even hourly weather conditions, particularly wind direction and velocity. You can see here, this is an example actually of a passage that I looked at from a Dutch East Indiaman sailing to the Cape of Good Hope. And the wind in this logbook is from the southwest. And so I looked at, as you can probably imagine, thousands of ship logbook entries, many thousands of ship logbook entries, and I used them to create graphs like this one. So this is actually created not just with ship logbooks, but also with intelligence reports, with diary entries, sometimes with newspaper accounts. And it really just shows, this is one part of the evidence that I built that shows that easterly winds became more common with the onset of the Maunder minimum. Westerlies, in red, were more common during the First Anglo-Dutch War, but easterlies were substantially more common during the Second War and much, much more common during the Third War. Now, this is really crucial because westerly winds, of course, blow from England, whereas easterly winds blow from the Dutch Republic. And so westerly winds are much more likely to give English fleets the weather gauge. English naval strategy actually deployed ships of completely revolutionary size with heavy artillery, and English naval strategy placed them in what's called the line of battle. So they arranged them in squadrons in a line that would sail at an opposing formation and fire broadsides at that formation before turning around and doing the same thing all over again. So they really depended on having the weather gauge, which let them actually deploy this formation. And so I argue in my book that frequent westerly winds gave English fleets a crucial advantage. They could expect to have the weather gauge more often than their Dutch opponents. And crucially, that may also have aided ambushes by English privateers. It may have allowed English privateers to more quickly sail from the coasts of England and then have the weather gauge when they ambushed merchantmen. And in fact, English privateering was especially destructive during the First Anglo-Dutch War, and much more destructive, much more effective than Dutch privateering. This is a depiction of the Battle of the Kentish Knock, and you can see here the English are in the foreground, whereas the Dutch are in the background. And the smoke, actually, it's difficult to see here, but the smoke seems to be blowing away from the English and towards the Dutch, and this is what we would have expected because the English were on the west relative to their Dutch opponents, and the winds were actually blowing from the west during the battle. Now, at the onset of the Maunder Minimum, things changed. First, the Dutch naval system changed. It adopted some of the best elements of the English system, including much bigger ships, including sailing with the line. But Dutch ship design produced vessels that handled better in rough seas than English ships. They were lower and they were wider, in part because Dutch harbors were so silty. So they actually had to build ships that didn't sink so far into the water. And in this context, the Dutch repeatedly exploited frequent easterly winds and, to some extent, stormy winds during battles to defeat English and later in the Third Anglo-Dutch War, French fleets. Dutch privateers were also much more effective. They seem to have sailed more quickly from Dutch harbors, and they seem to have had the weather gauge in engagement with merchant shipping, although it's more difficult to get a handle on how this exactly worked because privateering raids were less documented than major battles. And so the English won the First Anglo-Dutch War, whereas the Dutch won the Second and the Third Anglo-Dutch Wars, and I argue the changes in wind direction were an important factor behind the different outcomes of these wars. Not the only factor by any means, but an important factor. But I want to go a little bit beyond the battle now as well. Climate change, as I mentioned earlier, can influence military infrastructure. This is a letter from the most important Dutch admiralty to the Dutch States General, its ruling council, on the 6th of February, 1665, during an incredibly cold winter. Quote, "We have done our very best to build the 24 great warships you commissioned, but owing to the long freezing and other inconveniences, we cannot complete the ships as quickly as you expected. Those 24 great ships were an essential part of Dutch efforts to build bigger ships that could match the English." Now, there's no hint in this letter as to why freezing delayed the construction of ships. At first, I thought that canals in the Dutch Republic were frozen and that maybe it was difficult to get supplies to the shipyards. Then, a Dutch environmental historian, Peter van Dam, suggested that, in fact, maybe it was just more difficult to work in cold weather. And that might simply be true. The English also suffered from this, however. And in fact, English workers seem to have cannibalized their ships to create fires that actually helped them work. And so talk about a self-destructive process. And so the Dutch and the English seem to be equally affected by cooling in their naval infrastructure. So there was no benefit one way or another. Now, another really important way in which climate change influences infrastructure is seen by things like the Great Fire of London in 1666. The fire began in Pudding Lane towards the eastern periphery of London, and it spread in winds that blew hard from the east. So during the Maunder Minimum, during that Second Anglo-Dutch War, winds blowing from the east, which we can expect would become more common during a chillier climate. This is another depiction of the fire, and you can see here, from this vantage point, the winds do seem to be blowing from the east. In this picture, east would be to the right and west would be to the left. And this painting was actually painted in 1700, so it cannot be used as a direct sort of representation of what actually happened. But we get some hints from it, and that's really how it should be thought of. We can get some hints as to how people perceived, potentially, the impact of wind. Now, what happened after the Great Fire of London is that this was, of course, as you might imagine, extremely destructive to the English war effort. So it's extremely costly to rebuild the city of London. And as a result, in 1667, English great ships were kept in the river Medway. They weren't put out to sea because that would have been too expensive. And the river was actually sealed from Dutch raids by a really thick chain and by a few fortifications. Notably, as you can see here on this map, Sheerness. In June of 1667, the Dutch launched an audacious raid on the River Medway. They overcome the fortress of Sheerness largely through the incompetence of its defenders. But now they're in the River Medway, and they've encountered that heavy chain that should have kept them out. But driving and persistent northeasterly winds, it blew from just the right direction that allowed them to sort of push against this chain hard enough that they could break through it. And that then allowed them to enter the River Medway amid the great English ships and burn many of them and take others. This was then the crippling blow in the Second Anglo-Dutch War, and that allowed the Dutch to prevail in that war, and the English soon sued for peace. 1672, I should have put 1673 here. So 1672 to 1673 provides some of the most dramatic examples of weather influencing the course of a war, influencing almost every aspect of the Third Anglo-Dutch War. Throughout the summer of 1672, English officials complained about incessant high winds. On the 4th of July, Captain Narborough reports, quote, "Blowing weather hinders the taking in of our provisions, otherwise the fleet might have been out sooner." On the 6th of August, Narborough describes gusty, stormy weather, and he concludes that never was such weather known in these seas at this time of the year before now. On the 24th of August, a Dutch trader informs his English masters that this foul weather by sea and land the Dutch attribute, as they have reason, to a great providence. Now, the timing could absolutely not have been any better for the Dutch, because England had actually allied with France and the German states of Munster and Cologne. And they had launched together, the French and the German states, a massive invasion of the Dutch Republic. The Dutch fleet had been partially dismantled, so its marines and its guns could be used to protect the Republic against that invasion. So the Dutch were almost helpless at sea. And the English, with the French, were trying to invade from the North Sea. So there have been two fronts open against the Dutch, which would have been probably fatal to the Dutch Republic. But for more than a year, almost relentless storms held off the Allied fleet until the Dutch fleet could finally be reassembled and sail again because the invasion had been held off. And so what I did was I looked at English ship logbooks primarily, and I created this rather confusing graph of wind velocity during 1672 and 1673. And I used a dictionary that translates early modern nautical terms to modern Beaufort readings. And when creating this graph, realized that there's just a remarkable concentration of readings at Beaufort 8, which corresponds with really severe driving storm winds, and higher during 1672 to 1673. At least half of these records are at Beaufort 8 and higher, which is, again, shocking and borderline. You would never see that now, put it that way. You would never see that now. So my big conclusions then from my analysis of climate change and the conduct of war is, first, that climate change is really just one of many influences that shaped Dutch wars. The technological changes, political developments, economic conditions, and personal agency, which I get into much more in my book than I did now, all of these things matter at least as much, and that needs to be remembered. However, weather that became more common during the Little Ice Age and during its cold periods often benefited Dutch soldiers and sailors, and they exploited this advantage And I'm trying to figure out whether they understood it, whether they realized it. That's a tricky question, and we can talk about that later. And what I'm doing now, and I want to talk very, very briefly about the kind of work that I have planned in the next couple years, I'm embarking on a project that's called the Conquest of Cold, Confronting Climate Change in the Arctic, 1550 to 1720. And I'm really interested in relationships. So this is 2 articles I'm working on. First, between climate change, the migration of whales, the success of whaling, and then ultimately conflicts between different groups of whalers around Spitsbergen, which is an island that's part of the Svalbard archipelago, which is between the northern coast of Norway and the North Pole. I'm interested in those relationships from around 1610 to 1720. So this is an article I'm working on right now with an archaeologist. Then I'm also looking into connections between fur trading and Anglo-Dutch conflict in the Hudson Bay during the Maunder minimum from 1660 to 1720. So these are 2 articles that I'm working on right now. My big question here is, did Little Ice Age climate changes help trigger and then help shape conflict across the far north? But anyway, I promised I'd give a few possible lessons for the present and the future. So here they are. The first lesson is that even relatively small climate changes, and really when we're talking about the Little Ice Age, we're talking about shifts of 0.5 degree Celsius and sometimes 1 degree Celsius during the absolute coldest periods. Even these relatively small climate changes, in my opinion, can make wars more likely, can help trigger them, and then can help decide them by altering how they're fought. The second lesson is that the most obvious meteorological manifestations of climate change are not always the ones that matter most to human beings. Right? We have to be very careful in assuming that global warming will have a certain set of influences at local and regional levels, because we might be surprised by what actually ends up mattering most. The third lesson is that even moderate climate changes can yield both winners and so-called losers. I'm calling them losers, but there's probably a better term for that. Not everybody is impacted equally. And finally, moderate climate changes are rarely direct influences on human affairs. Now, I will actually add one more, and that's when we look at the past, we see the influences that moderate climate changes can have. When we look into the future, we might expect at least 3 degrees Celsius of warming by the end of this century relative to pre-industrial averages. And so there's a limit to how much climate history can help us. I feel like it can help us maybe envision some possible relationships that might unfold around the world in the next decade, 2 decades, maybe 3 decades. But after that, the future is really uncharted territory. Okay, thank you very much. And these are 2 websites that Professor Sam White did mention, climatehistory.net and historicalclimatology.com. Thank you so much. I would love some questions. Sure.
I wonder if you could talk to us about there's some intervening variables in there that struck me as not being discussed. We have the Maunder minimum, and we have the Greenwald, and suddenly the winds shift, but we don't kind of get the bigger context. Why? I wonder if you want to describe the circumstances in which this pretty critical story to be told about winds moving west or east from the west, westerly winds coming up the channel, up the North Sea in warmer weather, and down the channel to the west from the east in colder weather. What do you think's lying behind it?
We've talked a little bit about this. The idea is, and the idea I float in my book, is that changes in the state of the North Atlantic Oscillation, a seesaw of pressure over the northern Atlantic Ocean, are the primary culprit for these changes in wind direction. When the North Atlantic Oscillation is in a positive setting, we can expect more westerly winds. When it's in a negative setting, we can expect more easterly winds. During the Maunder minimum, it's often in a negative setting. During the Grindelwald fluctuation, it's often in a positive setting. I'm trying to figure out whether the positive setting of the North Atlantic Oscillation in the Grindelwald fluctuation contributed to more westerly winds in the North Sea region. But this is difficult for me to do because I have very few ship logbooks from that period. We really only get reliable ship logbooks after around 1660. I'm struggling with that. And then we really do get an awful lot of them. So I'm pretty sure about what I'm saying about the Maunder minimum, but the Grindelwald fluctuation, which is why I really didn't talk about wind directions in the Grindelwald fluctuation at all, I'm really not sure about that. Yeah. Mm. Yeah. Yeah. Oh, sure. Yeah. Mm. One slide. Okay. Okay. How? Oh, okay. So yeah, I'll talk about that. So the key point in lesson 1 is help. That's one of the key words there. They can be an influence behind wars, but they're certainly not a direct influence behind those wars. They can help shape wars, but they certainly don't determine how wars are fought and how wars are decided. And that's one of the key points really from this presentation, that they are one influence among many. Now, in terms of weather influencing military operations and the likelihood of wars, what you say is absolutely right. Weather can influence wars in a warm climate, in a cold climate. I mean, that's one of the thorniest things in climate history, really, is that a weather event can happen under just about any climate. So how can you then link that to a particular climatic regime? And it's really difficult to do. The key point there is that some weather conditions become more frequent. They become more common in particular climatic regimes. And so the idea here is that we can then link enough, if you look at enough examples of human action and those weather events that become more frequent, then we can start to say something about climate change. And this, something very similar is what people try and do with the Syrian drought and Syrian conflict there. The drought can really happen under any climatic regime. It could be a colder climate now, and a drought can happen that can make the Syrian civil war more likely. However, it's certainly much more likely that the drought would happen now than that it would happen in a colder climate. And so it's really all about probability. And it's really all about looking at enough of these possible relationships so that you can start to say something with more confidence. And that's really what I'm trying to do. Does that answer your question? Or? Okay. Mm. Sure, yeah. So I briefly touched on that, and briefly because really what the Frigid Golden Age and what I'm trying to do that's different from what other climate historians have done, for the most part, is that I'm interested in the conduct of war. So there's been a lot of research that tries to find correlations and, to some extent, causation between climatic change and conflict. And so I touch on that briefly, but it's not my primary concern. But undermining the legitimacy, for example, when food prices go up and people rioting think that the government cannot do anything to alleviate high food prices. When, for example, there's flooding and people blame the government for not properly maintaining flood defenses, which are completely legitimate criticisms of the government. So in those ways, we might see, say, at the beginning of the Dutch Wars of Independence, in those ways, we might see connections between climate change, weather, disaster, and finally, the lack of legitimacy of a government. Yeah. Yeah. Hmm. Mm-hmm.
So just prior to the overthrow of the regime, scarcity resources due to climatic change might, because there is a collapse of social order, there is collapse of whatever was keeping the government together. In that particular time frame, within that particular time frame, then climatic change might precipitate something that was already happening. For example, in California, Southern California, there is water scarcity. We don't expect people to start fighting this time. I'm exaggerating a little bit.
Yeah.
Because there is an assumption, an underlying assumption that the government, the state government, the councils, whatever organization, whatever bureaucracies or state government, governmental procedures exist, these will take care of the phenomenon.
Mm-hmm.
So what you are describing might be taking place, but as I said, it's only in very extreme conditions or as it is.
Well, first of all, I would broadly absolutely agree with that. Yes. And I think trying to isolate the influence of climate when there's so many other human influences involved is extremely difficult. I'm not sure if I agree that only in extreme meteorological conditions is conflict made more likely, and that's for a few reasons. First, that variability in weather, even when it's relatively mild, can, I think, be an important stimulus behind the sorts of things that might destabilize a society. So not necessarily an extreme, like, pulse maybe of drying or cooling for a year or two, but a prolonged stretch of variability that lasts a decade or 2 decades. This is something I didn't really touch on in this presentation, but it's certainly something that actually happened during the Lible Ice Age, because weather actually became less dependable from year to year, to some extent from month to month. And so this might actually make it very difficult to adapt to weather if you're in an agricultural society. That then might actually complicate agriculture outside of cities. This might then have some sort of destabilizing influence on the society. So I would say that finding that destabilizing influence is extremely difficult, and it simply does not work unless there are all kinds of other factors in place. There needs to be, as you point out, dissatisfaction with the government. I think that's absolutely right. But I wouldn't say that only extremes matter. I think we have to look for changes in averages as well. Yeah. But it's absolutely true, and I can't emphasize enough that changes in climate, changes in environment really, are only always one influence among many we talk about social instability. Yeah. Yeah.
I just have a question. When you cited the depopulation of America, and 60 million people died in this conflict with the Spanish, was that mainly due to the Spanish invasion of South America and Central America? 60
Yes.
million people killed?
Well, okay, so there's a long-standing scholarly debate about how they died and why they died. There's a black legend which dates back many decades, and that really argues that the Spanish themselves directly killed 60-odd million people. Then there's a newer concept really from environmental history that argues that it was in fact Spanish diseases, old world diseases brought to the Americas that reached virgin populations and spread wildly and killed millions of people, in conjunction with animals, lots and lots of animals and crops that were brought to the Americas and then changed relationships between indigenous peoples and the land. Now, more lately, I think the most recent, most cutting-edge scholarship about this is that what we really have is a whole range, a complex range of factors that were different on a regional and local scale. So one community reacted differently from another. So it was a mixture of human action and environmental changes that really doomed a large portion of the population of the Americas. And then, then the theory is, and you can actually read this, the most recent article about this is Maslin and Lewis dating the Anthropocene. I think it just came out last year. It's a compelling article, and the whole idea is that they're trying to date when human beings became the primary driver of environmental changes. And this is something that's then, according to some scientists, is then the beginning of the Anthropocene, when we are finally, for the first time, transforming the world's climate. And it's called the Orbis Spike. That's what they call it, 1610, the Orbis Spike, when we have a decline in temperatures brought about by human depopulation. And one of the criticisms of that concept is that when Europeans came to the New World, they also brought a whole bunch of ungulates, a whole bunch of animals that exploded out of control, essentially. They multiplied exponentially, and they nibbled through good chunks of the forest of the Americas. So how then do we make sense of that according to this theory? It's difficult to say. At the same time, you have, as I mentioned, depopulation in India and China. And was the depopulation there greater than the reforestation? Sorry, not depopulation, deforestation in India and China. Was the deforestation there greater than the reforestation in the Americas? That hasn't yet been established. So there's a lot of problems with this theory, but it is a really interesting concept. Yeah.
So you showed a lot of, not a lot of, but a vivid sense of how weather, the storm, affect the battle. And so I'm just curious, are people always the other side of weather, like being the victim, or do people actually know there's a rain to wall structure and the upcoming storm?
Yeah. It's a fascinating question. And Sam White has written some stuff about this and forwarded some sources to me that I can read about this, and I have incorporated them actually into the Frigid Golden Age. There were attempts to predict weather in the 17th century. They were largely unsuccessful. I don't think that people were aware of, for example, the difference between a Grindelwald, since they certainly didn't use these terms, of course, the difference between a Grindelwald fluctuation and a Maunder minimum. They did, however, and I have a whole sort of half chapter about this in the Frigid Golden Age, they did keep track of weather extremes. And they were aware that weather extremes, the frequency of weather extremes fluctuated with time. And in the Dutch Republic, the sources I've looked at suggest that these attempts to track the frequency of weather extremes were accurate at a generational level. So, for example, when someone thought back 30 years into the past and said, this winter is as severe as the one 30 years ago, they were almost always right from the sources that I've looked at. Or this rainstorm, or this drought. And when you go back further than that, things become a little bit more murky. So there was some attempt to track how weather was changing, just not the way we do now, and that's in part because statistical reasoning, the kind of statistical reasoning that you need to really track changes in average weather over long periods of time didn't exist yet and wouldn't exist for some time. So, but what I'm really looking for always are those sources that say, weather these days is just a lot colder than it has been. Yeah, great question. Mm-hmm.
Do you have any comment on that?
I certainly do, yeah. I received an email at around that time asking me if I could advertise cooling equipment on historicalclimatology.com and our climate history network because a new Maunder minimum was coming. And I did not actually advertise air conditioners. So, first of all, the impact of changes in solar radiation and solar activity pales in comparison right now. So these kind of relatively minor changes in solar activity pales in comparison to the warming impact of greenhouse gas emissions. So we might well have a cooling influence on our planet from changes in solar forcing, as it's called. But that will not in any way override the warming impact of greenhouse gas emissions. So we might have a slight, maybe a very slight slowdown in global warming, but we certainly won't have another cold episode of the Lible Ice Age. So I don't have to advertise air conditioners. And maybe I lost out on a lot of money. I don't actually have to advertise air conditioners on historicalclimatology.com. Yeah. But this was all over the place, actually, and it's testament to how quickly these ideas can spread when someone misreads a scientific article based on solar modeling. Yeah. Yeah.
Yes, you spoke about a volcanic eruption adding sulfate to the atmosphere, causing a deflection of the sunlight, resulting in cooling. Are you familiar with some of the discussion of when 9/11 occurred, all the air traffic landed and the skies cleared up, and then wasn't there a change in like warming or something? There was an increase in solar insolation. Do you know anything about that?
I don't, actually. I would speculate that the impact was way too short term for it to have, but maybe John Brooke can.
Well, I do remember hearing about this, and there was, the skies definitely cleared, and there was certainly a change in cloud formation
Yeah.
for about 2 weeks.
Yeah.
That's about it. I don't want to get further than that. But definitely want to see what I mean, the contrails move an enormous amount of crap in the atmosphere. And that becomes a particle that attract clouds, and helps create clouds. So basically, between then and about mid-September, there was a lot, I think this could be documented.
Is there an article about that? Do you know? That sounds good to me. That would be interesting to see. Have you? I feel like there's a. I can't remember the names now. There's an article that argues that the change in air traffic with the jet age, so the planes used to fly lower, now they fly higher, had an impact on the world's climate because lower vapor trails, I think, have a cooling impact, whereas higher vapor trails have a warming impact. Correct me if I'm wrong. This is. Well, yeah. Yeah. Yeah.
Number of articles published on it, the sky's clear, and the height of the cloud and the type of the cloud affects it causes warming,
Okay.
reflecting light or absorption.
Had a really bright.
It's one of the most complicated things in the climate model.
I can imagine. I had a really bright student last year who was the daughter of an Air Force captain who wrote a short essay about this, which was fascinating stuff. Yeah.
You mentioned that you want to explore the Anglo-French and the border trade. What
Yeah.
do you think you're going to see there?
Well, I went to the Hudson Bay Archive last year, and I found just a rich wealth of documentation on ship journeys in the Hudson Bay and on the day-to-day operations of fortifications and fur trading posts in the Hudson Bay. And I found, in particular, a lot of documents in French and in English, the French complaining about the English and the English complaining about the French. And what I'm trying to do now is get a graduate student to work on some of these documents to try and find and quantify weather references in these documents so I can start building connections between the kind of weather and the kind of sea ice concentrations that we might expect in cold years of the Maunder minimum and conflict between the English and the French. So I don't know what I'm going to find, to be honest. I don't know. I know that there's sources that are intriguing right now, and now I just really want to quantify them and get to work on them. But I'm more interested in the Svalbard Spitsbergen article right now because it will let me actually go to Svalbard and Spitsbergen, and I'm quite keen on that. Thank you.